110. This is lab number 6. We're going to talk about simplifying or reducing rational expressions and then multiplying and dividing them as well. So let's start off with this example here. When we're going to simplify a rational expression, one of the first things that you're going to want to do is try to factor the numerator and the denominator in order to do that. So let's try to factor the numerator here, 8y plus 12. 8 and 12 both have common factors, 2 and 4. We want to use the largest of those, which is 4, and that would give us a parentheses of 2y plus 3. And then in the denominator, 6y plus 9, we would take the greatest common factor of 6y and 9 would be 3. And 3 times 2y gives me 6y. 3 times 3 gives me 9. And then once you have it factored, you want to cancel out matching factors. So 2y plus 3 cancels out a 2y plus 3. And our final answer is 4 over 3 for that, to simplify into lowest terms that example. If you were asked to find the domain of that, you would need to set 3 parentheses 2y plus 3 equal to 0. When doing that, the 3 divided by 3, it goes away and gets us 2y plus 3 equals 0. And then you would solve that equation by subtracting 3, and that would give us 2y is equal to negative 3 divided by 2, and y negative 3 over 2. And so our domain for that would be all y as long as y does not equal negative 3 over 2. Interval notation for that would be from negative infinity to negative 3 over 2 union negative 3 over 2 to infinity. So that would be our restrictions on that particular problem. Let's look at another one, a little bit more involved factoring here. So we have x squared minus 6x plus 8 over x squared minus 16. We're asked to reduce that into lowest terms. So the name of the game is factoring, and because this has 3 terms, we're going to use the x method of factoring for that. So multiply to be 8, add to be negative 6. 1 times 8 is 8. The negative 6 is the middle term in the bottom. So numbers that do that would be negative 4 and negative 2. Because there's a 1 in front of x squared, that allows me to use the shortcut x minus 4, x minus 2 as my factors. And then the denominator, x squared minus 16, is a difference of squares because it has x squared and 16 is 4 squared. And that allows me to factor again x plus 4 and x minus 4. We want to cancel out matching factors, leaving us x minus 2 over x plus 4. Keep in mind, if you're asked to find the domain of that you need to find the domain before simplifying. So you would end up being responsible for setting x plus 4, x minus 4 equals 0. Split those apart and solve. Here we have x is negative 4, x is positive 4. So your domain would be x does not equal plus or minus 4. Interval notation, negative infinity to negative 4, union negative 4 to positive 4, union 4 to infinity. Would be your domain for that particular problem if asked for that. The next problem. This is a multiplication problem that we're asked to simplify and find the product of this problem. So what we want to do is factor all possible pieces. So we have 3a squared minus 2a minus 8 over 3a squared plus 14a plus 8 times 3a plus 2 and over 3a plus 4. So good news is this second fraction we don't have to factor, but we do have to factor the numerator and the denominator of this particular first fraction. So it's going to be an x method of factoring for this. 3 times negative 8 is negative 24. Negative 2 in the bottom. So 3 times 8 is negative 24. Negative 2 from the middle. We want numbers that do that. So that'd be negative 6 and positive 4. And because it is a there's a number in front of the square term, we need to go through the grouping step. First two together, 3a parentheses a minus 2, second two plus 4, a minus 2. So the numerator of the first fraction is 3a plus 4 and a minus 2. And let's factor that denominator. Same method, using the factoring method of the x method. 3 times 8 is positive 24, and 14 goes in the bottom. 12 and 2. And again, I'm going to 3a squared plus 12a plus 2a plus 8. And group the 3a, a plus 4 plus 2, a plus 4. And that'd be 3a plus 2 and a plus 4. A plus 4. That's the factoring of the denominator. Times 3a plus 2, 3a plus 4. And we can cancel out 3a plus 4 and 3a plus 2 diagonally, leaving us a minus 2 over a plus 4. There's the simplified version of that multiplication problem. The next example is a division problem. The rules for division problems are exactly the same as rules for multiplication problems. The only difference is that we should flip the second fraction first. So we're going to take that fraction and rewrite it, this entire problem, as a multiplication problem. And then if it were polynomials, we would factor the numerators and the denominators and cancel matching factors. Since this is just rational expressions with exponents in there, we're going to just cancel out across and diagonally and vertically. So I'm going to go vertically first. I see a 3 goes into itself once and into 9 3 times. 6 and 8 have 2 in common. So that'd be 3 and 4. And then I'm going to cancel diagonally now. 3 cancels 3. 1 n cancels 2 of those, so that leaves an n squared. M squared cancels 2 of those, leaving a plain m. So we have 1 on the top, and n squared times 4 times m. So that's 4m n squared for the solution, or the simplified version of that example. So that's lab number 6 for Math 110.